All right, angles of elevation and depression. So let's say your eyesight. If you look straight ahead and then you look up from there, it's called elevated. So if you elevate where you're looking, that would be up here. And I'm going to draw a line going across, and this is just your eye level. You just draw an eyeball and then your eye looking at eye level, and then this is going to be called the angle of elevation if you're looking up from eye level. Angle of elevation. And again, that's right here, and that's how far up. And I'm extending that arrow to go up from eye level. And notice what that makes. If we make a little connector right here, up and down, that makes a right triangle. And then let's go ahead and draw an angle of depression. So draw another eyeball, and then draw eye level from that eyeball. And then let's say you're looking down, maybe looking at the ground now. So if you're looking down, that's called depression. D means down, that prefix right here. And notice what happens if we draw that angle from eye level. I'm going to draw an arrow to show that angle. And I'm going to call that angle of depression. That's the angle symbol. And it's depressed, it's sad, so it's looking down. And what does that angle of depression make with the eye level? A right angle. So we're going to put that right angle symbol in there. And those are just the two main words from this topic. So angle of elevation, angle of depression, and now we're going to use our SOHCAHTOA, or our trig ratios, to find out missing sides from these right triangles. Alright, just like in the game of chess, let's come up with a strategy for these types of problems. First, we want to draw a picture. This is the most crucial piece of this, representing each word problem. And you want to fill in everything that you know, all the known angles, all the known sides, and then we're going to use trig, or SOHCAHTOA, to solve for the unknown sides. So for instance, example 1. Alright, let's say Olivia is flying a kite and holding the string from the ground, and she lets out 30 yards of string. If the angle of elevation is 47 degrees, what is the height of the kite? Well, if you've ever flown a kite, you know that the string, if you're flying it, if it's up in the air, it's almost always going to be slanted, because the string is going to be fully extended because the wind's taking the kite. So imagine for a second, it's asking what is the height? Well, we know height is always perpendicular to the base. And in this case, the base is just the ground. So you can draw the ground. Yeah, you can even put some grass on it. What do you know? So there's your ground. And you have that height, which is, again, we said is perpendicular. And I'm going to put a right angle symbol to show that. And it says the angle of elevation is 47 degrees. Which angle is that? That's the one that's from the ground. Remember what we did up top? We talked about it's from eye level looking up. Well, here it's from the ground looking up. So it's going to be that angle right here. So I'm going to fill in 47 degrees. And I have one other number here. It says 30 yards of string. Well, where's my string? That's up here. And that's the hypotenuse. It helps if you label that hypotenuse, and then the only thing you're thinking of is the words opposite and adjacent. So we want to know the height. I'm going to call the height the x. And now, look, from my angle of elevation, in reference to this angle, x is opposite. So I'm going to write OPP over there. And from this angle, the length on the ground from there to there would be the adjacent. But we're not even going to use that, are we? So I'm going to write SOHCAHTOA. I should always write this when I'm doing trig. That way I just reference it. And which one includes the known, which is the 30, the hypotenuse, which the unknown, the opposite. So which one has hypotenuse and opposite? Look next to sine, we have OH. So that's the one we're going to use. So I'm going to write sine of 47 degrees equals opposite over hypotenuse. And then I'm going to fill in, my opposite was x, my hypotenuse is 30. I'm just filling those in to my ratio. And I'm going to solve this proportion. So cross multiply, and that's really sine of 47 over 1. So we have 30 times the sine of 47 equals x times 1, which is just x. I'm going to type that in my calculator. I'm going to make sure that I'm in degree mode. You have to be in degree mode. If you're in radian mode, it's going to be wrong every single time. And I got that x equals about 21.9 yards. All right. So just remember, the hardest things to remember are when you set up those ratios, it's always in reference of the angle that you know. So from 47, that's opposite, and this would be adjacent. And the hypotenuse is always opposite your C. Remember, the sun shines on the sea. There's the sun shining on the sea. All right, example 2. Let's say a big bird. How about Big Bird? Flying makes an 8-degree descent to the ground. So descent means he's going down. In search of a worm. There's our worm. And if the ground distance from the bird to the worm was 86 feet, how high above the ground was the bird? All right, maybe we should shrink this worm. I feel like the worm would probably eat Big Bird if he's that big. There we go. A little better. So I'm going to draw my picture. It's an 8-degree descent, so that means from level. You can think like from eye level. So from level or parallel to the ground, it's going to be an 8-degree descent. And that's actually going to be a much more acute angle than what I drew, but we're just drawing a picture. So that's 8 degrees. And remember what this makes? It makes a right triangle. If I connect the bottom of that up to the level, that makes a right triangle. And it says the ground distance was 86 feet. Well, this is our ground over here. So that ground distance from up here is 86 feet. So if this is 86 feet down here, from there to there, and this basically makes a rectangle, so that's going to be 86 feet from up here, because we know opposite sides are the same. So now I have my picture. I have 86 feet, 8 degrees, and what do I want to find? How high above the ground? So remember, height is this guy right here. So I need how high the bird was. Well, do you guys remember, what's it called if you draw a line? And that's what we have. We basically have a line drawn through 2 parallel lines. These are your parallel lines. What are those called with the 8 degrees and this line over here? Those are called alternate what? Interior angles. So that means this one's also going to be 8 degrees. And now we know this is going to be our x. We have our 8 degrees. So what trig ratio, if we look at SOHCAHTOA, what trig ratio are we going to use? Which one uses, and I'm going to label it in reference to 8 degrees, this is the, whoops, what is that? The opposite. This is our hypotenuse, and this is our adjacent. So which ones are we going to be using for our 8 degrees? Well, the opposite, because that's our unknown, and our known value of 86, which is our adjacent. Which one uses opposite and adjacent? Tangent. So I'm going to do tangent of 8 degrees equals opposite over adjacent. I'm just going to rewrite that now, plugging them in. It's tangent of 8 degrees equals, opposite of it is x, adjacent to it's 86. And now I just cross multiply. That's really over 1. So it's x equals 86 times tangent of 8 degrees. Again, make sure you're in degree mode and do 86 times tangent of 8, and that'll be your answer. Alright, and our answer is 12.1 feet, about. Alright, thanks Big Bird. Hope you got the worm.